welcome now to week 5. We're looking at matrix transformations and calculus. The first bit of this topic is about rate of change. Now, essentially, it's a fancy way of talking about the gradient. So dy dx, which we know as the gradient function. But essentially, it's your change in y over your change in x, which is, when you have a straight line, for example, how you work out the gradient. So it's how something changes with respect to something else. So we've got a grid, we've got to sketch a graph, a rate of change of y with respect to x is always 0. So essentially, when is a gradient 0? Now that's going to happen when you just get a horizontal straight line. So as you change the x coordinate, the y coordinate doesn't change. So we end up with a horizontal straight line. It says on the graph, the rate of change is always positive. So here, what we need is a straight line just with a gradient of 0. And it doesn't matter, it doesn't need to go through 0, 0. We're not talking about directly proportional. It just needs to be a positive straight line. Might as well do it through 0, 0, but there's no reason to. Okay, now we've got 5 graphs. And the question asks us different things about it. So the first bit is the rate of change is always negative. So that means it's always negative, so it's always going to be sloping downwards no matter which point we look at. So if we have a look, that's going to be graph C. So graph C, we know, is always negative. Okay, the next bit says, is always 0. So exactly like we just drew the other one, we're essentially looking for a horizontal straight line. So we've got this one here. So this is always 0. And the last bit says, as x increases, the rate of y with respect to x decreases. So we're saying as x goes up, right, the rate of y decreases, so the gradient decreases. Now when we've got a curve and we want to think about the gradient, we're just going to think about the tangent at lots of different points. Now if we have a look, we start off with a steep line over here, and it's less steep and less steep. So the answer here would be A. Right, next bit is differentiation. And this is quite a nice topic because all you do is when you have something to differentiate, so you'll have y equals x to the power, let's put a number in front, so k x to the n. dy dx, all you do is you bring that number down and you multiply by that power. And then you take 1 away from the power. So you multiply by the power and you reduce the power by power, and you reduce the power by 1. So, with this question here, we've got 2x to the 10 minus 3 over x squared. So before we can start to do this, our first step is going to be to rewrite this indice in a way that's easy for us to differentiate. So we've got 2x to the 10. Now, because it's on the denominator, we're going to bring it up. And when we do so, that 2 becomes a minus 2. So now, when we do dy dx, we multiply by the power 2 times 10 to give us 20x to the 9. And then we bring down this one. So minus 3 times minus 2, which is plus 6x. Minus 2 minus 1 gives us minus 3. So be super careful with negative numbers. We've got some more here. Now when we've got something with something on the denominator, we want to be able to split it out. So we split the numerator. So this is the same as saying 2x to the 7 over 3x plus 15x squared over 3x. So if we take the first bit, we'll get 2 over 3. And we can cancel down. So we've got x to the 7 divided by x. Now remember, when we divide indices, we're taking away. So we get x to the 6. 15 divided by 3 gives us 5. And then x squared divided by x, 2 take away 1 is x. Now we're going to differentiate it. So remember, we multiply by the power, 6 times 2 giving us 12. Divide by 3 is going to give you 4. So we're going to end up with 4x to the 5 plus 5. Because remember, 5x, the gradient of y equals 5x, is just 5. So we want to know what that equals, what x equals when all of it equals 133. So I can take away 5 from both sides. 133 take away 5 is going to give me 128. If I then divide by 4, 12 divided by 4 gives me 3, 8 divided by 4 gives me 2. And you should know that the fifth root of 32 is 2. So your answer is 2. Next bit says, work out the rate of change of y with respect to x at a certain point. Now remember, rate of change, just a fancy way to say differentiate. So step 1, we're going to open out those brackets. X squared times x squared is going to give us x to the power of 4 minus 9x squared. And now we're going to differentiate it because they've asked us for the rate of change, which essentially means that they want you to differentiate it. So when we differentiate that, we multiply by the power, so bring that in front, reduce the power by 1, 4 take away 1 is 3. Same here, minus 18x. And now we're saying when x equals minus 2, what does dy dx equal? So we're going to get 4 times by minus 2 cubed minus 18 times minus 2. So 2 cubed is 8. So we've got minus 8 times 4 to give me minus 32. 18 times minus 2 is minus 36. Minus and a minus make a plus. 36 minus 32 to give me 4. Okay, the next bit, we're looking at the gradient of a curve. Now, exactly the same. Rate of change, gradient, all of these things are different ways when we talk about dy dx. So when we think about a curve, so any curve at all, if I take a random curve, if I wanted to know what the gradient was there, I would have, in GCSE, you draw a tangent, you'd find change in y over change in x. That's all dy dx is telling you. It's giving you, if you substitute the x in, what the gradient will be at each of those different places. Okay, so let's take this first one. We've got work out the gradient when x is minus 1. It's given us dy dx. So essentially, all we're going to do is substitute in some values. So when we substitute our values in, we've got 9 minus minus 1 cubed. Now, even though you might be able to do that really quickly in your head, just write it out. You know, 9 minus minus 9 plus 1, so the answer is 10, just to avoid making any silly mistakes. Right, work out the value where the rate of change of y with respect to x is 1. Again, rate of change, same as dy dx. So we've got 9 minus x cubed equals 1. X cubed is going to equal 8. So x must be 2. Because the cube root of 8 is 2. Right, slightly longer question here. We've got a curve has an equation. The gradient, we see gradient, my brain's going to go dy dx. So first let's just work out dy dx. Bring the number down. the power down and take 1 away. So we get 3x squared plus 2ax. Now we're saying when x equals 4, what is dy dx? So when x equals 4, dy dx is going to be 3 times 4 squared plus 2 times a times 4. So that's going to give us 4 squared, 16, times 3, so 48. 2 times 4 is 8, so 48 plus 8a. Okay. And when x equals minus 1, dy dx is going to be 3 minus 1 squared plus 2 times a times minus 1. So we're left with minus 1 squared, which is just 1, times 3, plus, well, it's going to actually give me a minus 2a. And now what does the question say? The one when x equals 4 is twice x equals 1. So that tells us 48 plus 8a is twice, so 2 lots of 3 minus 2a. So when we open out those brackets, we've got 6 minus 4a. Put all the a's on one side. So you're going to get 8 plus 4, so 12a. And then you're going to have 6 minus 48. So you get minus 42. Divide them and you've got minus 3.5. So your answer would be minus 3.5. And that's 5 marks. It's quite a lot of marks. And you just follow that process. Okay, so we've got a curve, y equals fx. dy dx has given us what dy dx is. When x equals minus 2, the gradient is 12. Okay, so we're going to substitute in x is minus 2. So when x is minus 2, dy dx is going to be 3 over 2 times by minus 2 minus k times minus 2 to the power of 4 plus k. And we know all of that equals 12. So now if we sort that out, we've got minus 2 is going to cancel there. We're going to get minus 3. Minus 2 to the power of 4, giving us 16. So we've got minus 16k plus k equals 12. Move the k's onto one side. We're going to get 15k equals, so if we move the k's onto there, we've got minus 3 minus 12. So we've got minus 15. So k must equal minus 1. And you may have rearranged that differently, but you should get the same answer. So now we're going to think about what stationary points are. So stationary points are where you have a minimum or you have a maximum. So, for example, if I have a quadratic, think about a quadratic, and I have a positive quadratic, this has a minimum point. So there's a point at which it's the lowest. Now if we have a look, the gradient just before that is negative and just after it is positive. So what happens is you get your turning point just before it. In this case it's negative and then it'll be positive. So when you have a stationary point, you're always going to get also a change in the gradient either side of it. So here we've got a maximum, and in this case just before it's positive and just after it's negative. You can also get what's called a point of inflection. Now this one's a bit more special, right? The gradient just before is positive, but so is the gradient afterwards, right? And it doesn't matter, you could draw it the other way around, at which point you'd get it negative followed by a negative. So there's 3 types of stationary points: your minimum, your maximum, and your point of inflection. So maybe what we do, if we write here, gradient just before and then just after will be different. So in this first example, just before it's negative and just after is positive. So we see a change in gradient. In this one here, it's positive and then it's negative. And at the point of inflection, it's the same. So it's positive and positive, and it's negative and negative. But at the actual point, so at the actual point of either inflection or minimum and max, dy dx is always 0. So at a turning point, which is sometimes called a stationary point, so it's where the curve changes direction, it's going to be the case. Right, so we've got show that we've got a curve has exactly 2 stationary points. So step 1, we're going to be differentiating it. So you see stationary points, you see turning points, your brain's going to go differentiate, differentiate. Okay, so we bring the power down and take 1 away. And when we do that, we get 3x to the 4 plus 4x cubed. And now, at the stationary point, we know all of this equals 0. Right, what can we take outside the bracket? We can take an x cubed outside the bracket, giving us 3x plus 4. And then we can see x equals 0 or x equals minus 4 over 3. And we've shown our exactly 2, because we've got exactly 2 answers. Okay, we've got the curve y equals fx has dy dx, long thing. It has 1 stationary point when x equals minus 2. And we want to show it's a point of inflection. Okay, so first of all, if x equals minus 2 and it's a stationary point, then dy dx must be 0. So we're going to say when x equals minus 2, dy dx equals minus 2 plus 2, minus 2 plus 2, both of those brackets become 0, equals 0. Okay, so we've shown that there is a point there. Now what we want to do is we want to take a point either side of it, right? So, and because it's a point of inflection, we should find the value stays exactly the same. So let's take x equals, when x equals, let's say when x equals minus 3. So it's smaller than minus 2. So when x equals minus 3, dy dx equals minus 3 plus 2 to the 6, minus 3 plus 2 to the 4. So we're going to end up with 2 minus 1 to the 6, which is just 1, and plus 1 and plus 1, which equals 2, which is positive. So the gradient to the left is positive. Right, let's say we take 1 to the right. So let's say when x equals minus 1, dy dx is going to give us minus 1 plus 2 to the 6, plus minus 1 plus 2 to the 4, which is going to give you 2 minus 1, which is 1, 1 to the 6, which is 1, plus 1, which equals 2, which is also positive. Right? And we could say as both the gradient, as gradient before and after, right, the same, this is a point of inflection. And that would be your method to do that. There's some other methods you could use, but I think this one makes the most sense. Okay. So, I've got one more question here for this section. We've got the continuous curve y equals fx has two stationary points, and it tells us a little bit about them. Now we want to know where is the stationary point. Now we know that happens when dy dx is 0. So straight away we can hopefully see it's when x equals -1 and when x equals 2. Oh, okay, so we're still part of the same question. This makes more sense. And we want to find it is giving us the y values. So 3 and 1. And we want to find out whether it's a maximum or a minimum. Now remember, when you have a minimum point before it, you have a gradient that goes negative, and after you've got a positive gradient. When you've got a maximum point before it, your gradient is positive, and after it, it is negative. So if we take that -1, before is positive, after is negative. So it must be a maximum. For the 2, before is negative, and after in this case is not either of these, so it's not a minimum. So it must be that point of inflection. And it's not part of a different question. The same question. It's part of a totally different question. I hadn't seen the f-1 and f2. Okay, next bit. Matrix multiplications. I know I'm talking fast, but please, make sure you pause this video, go back over it. It's just so if there's only certain questions you got wrong, you can sort of zoom through them. When we multiply matrices, you do each row of the first matrix multiplied by each column. So your fingers do that. So you go along and down. Okay. So if I was to so everything is pairwise. Now, when we multiply a matrix, it goes on the front. So if you do A multiplied by B, it's BA, not AB. So each row is multiplied by each column. Now this will make more sense when we have a look at a question. But also remember that your calculator, if it's in the calculator paper, I know that's after half term and still a little bit a while away, well after half term. So if it's in the calculator, you can use your calculator to multiply them, but they'll be worth a lot less marks. Okay, so we've got AB equals C, right? So now A is a 2 by 2, because you've got 2 rows and 2 columns. B is a 2 by 1. Rows go first and then columns. So you've got 2 rows and 1 column. Now you can only multiply things if these 2 middle bits are the same. And you will get these 2 outside bits. So we've got 4 minus 1 minus 7, 2, multiplied by s minus 5 to give us minus 1t. So you're multiplying each row by each column. So essentially you've got 4 times 5 plus minus 1 times minus 5. Sorry, not 4, it's not 5, that's an s, apologies. Let's write that more clearly, s. So you've got 4s minus 1 times minus 5, making plus 5 equals minus 1. Okay, so we can solve that quickly. Bring the 5 onto the other side. So we get minus 6. So s is minus 6 over 4 minus 3 over 2. You might have written it as 1.5. Next one, we've got minus 7 times by the s, 2 times minus 5, and that equals t. So we end up with minus 7s minus 10 equals t. But we know s is minus 1.5. So we're going to do minus 7 times by minus 1.5. So you're going to end up with 10.5 minus 10, which must be 0.5. So s is minus 1.5 and t is minus 0.5. Excuse my voice. And then we've got AD equals I. Now what does that I mean? So that's your identity matrix. So I equals 1, 0, 0, 1. Essentially, it's like timesing by 1 for matrices. When you multiply by I, you just end up with the same thing. So if I have A multiplied by I, I'm going to end up with I multiplied by A, which is just A. Okay, so A, it tells us, is 4 minus 1 minus 7, 2. So 4 minus 1 minus 7, 2. D is 2, 1, 7U. And we're saying this equals 1, 0, 0, 1. So we know when we do this row, because this is the second row, by the first column, I get 1. So minus 7 times 1 plus 2u equals 1. So we get minus 8 plus 2u equals 1. And work out the value of u. So we've got A multiplied by D multiplied by D minus 7 plus 2u equals 1. Oh, I've made that 8 somehow. I wondered what I'd done wrong. I wish I could say it's to see if you're awake, but here we go. So minus 7 plus 2u equals 1. So 2u equals 8. So u equals 4. There you go. I knew it had to work out nicely. Also, in an exam, that's quite a good sense check. If you're getting a number that looks a bit strange, you might have done something wrong. So have a double check and go look back. Okay, next question. Work out the values of A and B. If we've got a number outside, it means everything is multiplied by that. So here, this means 3A and 5A. And on this side, we've got 4 times 2, so 8A plus 12. So it's like having a number outside of a bracket. So now I've got 3A equals 8A plus 12. So if I put all the A's on one side, 8 minus 3 is going to give us 5A equals 12. So A is, so if we do 8 and then we move minus 12, doesn't matter which way you do it. Whether you put the 12 on that or the one or the other side, just make sure you get the minus in. So A is minus 12 over 5. And then we've got 5A equals 4B, but we know that A is minus 12 over 5. So we get 5 times minus 12 over 5 equals 4B. So we've got minus 12 equals 4B, so B must be minus 3. So minus 12 over 5 and minus 3. The next one, we've got an identity matrix again. So we're going to be multiplying this out. So remember, we've got the first row times by the first column. So you're going to get 2 times m to give you 2m. Minus 1 times minus 2 to give you plus 2. And remember, the identity is 1, 0, 0, 1. So that equals 1. Then here you've got so then you can choose another equation. So let's do the one with 0. So we've got our first row, this time multiplied by our second column. M times 2, 2m. Minus 1 times minus 1 is going to give us plus 1, and that equals 0. And so we've got 2 equations. We could use either of them to work out m. I would use the first one, so we get 1 minus 2, so minus 1, m equals minus a half, and I would check it with the second one, so 2m equals minus 1, m equals minus a half. Because remember, you're in the exam, you want to try bringing checks wherever you can, just in case. Okay. So matrices allow us to represent transformations such as enlargements, rotations, reflections. So if I want to figure out which is which, you just take some arbitrary point and you say, what happens to it if I do something to it? But there are some which are well worth learning. And if you learn them, it makes it a lot easier and you don't need to think about the combination. So you've got a rotation, 90 degrees, anti-clockwise, and these are all about the origin. You're going to get 0, minus 1, 1, 0. 180 degrees is going to give you minus 1, 0, 0 to minus 1, which makes sense because you're changing them to minuses. In terms of reflections, you could have a reflection in y equals x. So your y's and your x's are swapping. You could have a reflection in the line x equals 0. And again, we can prove these and we will, but if you're good at learning and you've learnt them, it just makes it easier. And if you have any enlargements, the amount that it's enlarged by goes across the leading diagonal. That's what that first bit's called. And these zeros represent the origin where it goes through. Okay, so let's look at some questions. We've got two transformations, a rotation 90 degrees clockwise and a reflection. So now we're looking at the combined transformation. Now, with combined transformation, if you have A followed by B, that would be BA. So remember, it was always the second and then by the first. So in this case, we can say, well, 90 degrees clockwise. It's one of the ones that we have learnt. And your reflection. And we're going to put those in. And when we do that and times them up, we've got our first row times by first column, 0, 0, 1 times minus 1, which gives minus 1, 0, 1, that's just 0, so we get a 0 there, 0 and a 1. So that would be your single matrix that combines those two. Now say you'd forgotten what a reflection in the line y equals x looks like. There are different ways we can do that. So we're going to have a look at a few of them. Right, so now we've got this last question left here, and we're going to be looking at how we go from each of these. So if we've got a reflection in the line y equals minus x, and we don't know what the matrix is, we can think about what would happen to a unit square. So if I had a square here, I had the line y equals minus x, which looks like that, it would go here. And what you're really looking for is you're saying what happens to this point and what happens to this point. So this point here is 1, 0. And it goes down here, and what's happening to it? It's becoming 0, minus 1. Think of it almost like a coordinate. And this point here, which is 0, 1, is going here and become minus 1, 0. So actually, the reflection in the line y equals minus x results in a matrix where this becomes this, so that goes here, and this one goes here. So that's your reflection in y equals minus x. We've got a rotation of 90 degrees anti-clockwise in the origin. Now again, if you didn't know what that looked like, you would take your unit square, oh no, not reflection, sorry, a rotation. So rotation, 90 degrees anti-clockwise, and you say what would happen to that. So if I was to draw my unit square again, and I'm rotating it anti-clockwise, 90 degrees. So I'm saying to myself, what's happening to each of those points? So this point here, this point here, this point here, this point here. This point comes down, it's going to go here. So this was the point, like we said, 0, 1, and that's going to come down over here and become -1, 0. This point here, because when I bring it down, it's going to come here. This point here is the other point I want to think about. What happens to that when I rotate it about the origin? Now this point over here, which is at the moment 1, 0, so when I rotate that, that actually comes up to this point here. And those are the points that you're concerned with. So you say 1, 0 becomes 0, 1, and 0, 1 becomes -1, 0. And that's the same as that. If you have a look, that's the same as what we said over here for a rotation of 90 degrees anti-clockwise. Okay, then we've got a reflection in the x-axis. And if in exactly the same way, we think, okay, so this is my x-axis. You have our unit square here, it goes here, and I say, what happens to my first coordinate, which is 1, 0? Well, it stays the same. So that's just 1, 0. What happens to this one up here, which is 0, 1? It comes down here and becomes 0, -1. So that would be that matrix. Anyway, that isn't what this question's asking. It's asking us to say, what happens when we have all of these things followed by each other? So we're going to think of them as pairs. So we're going to have, and we're going to go sort of backwards, if you like. So we're going to take these two first, because remember, we're always going back. So we can take 1, 0, 0, -1, which was our reflection in the x-axis. And then just before that, we did 0, -1, 1, 0. We're going to multiply them first. So first row, first column, we get 0, -1, -1, 0. We then take this that we found, and we're going to multiply it by our initial one. And when we do that, we see we end up with 1, 0, 0, 1, which is the identity. And we've done that question. Okay, so the final question we've got for you today is different shapes. So we've got shape A matches by an enlargement. Now remember, an enlargement is going to look like, let's call it n, whatever the value of enlargement is, if that's around the origin. Center the origin. Shape B is a rotation of 180 degrees. Shape A can go straight to shape C. And you're going to use matrices to show that it's an enlargement center the origin. Okay, so our first thing we're going to do is we're going to say, okay, what's happening here? We've got our matrix and we are multiplying it by, so we take our matrix and we're going to multiply it by them by each other. Okay, so I would have 3, 0, 0, 3, which is my enlargement, and that takes me from A to B. So that's going from A to B. Then we've got a rotation through 180 degrees. So that was -1, 0, 0, -1, and that's going from B to C. So what we want to do is we want to multiply these together. Remember, it's the second one and then the first one. 0, -1, 3, 0, 0, 3. When we multiply them together, we're going to get -3, 0, 0, -3, which is an enlargement scale factor -3. Right, and that would be sufficient to prove that. I hope that makes sense, and I hope that's been useful. Week 6, which is next week, that'll be the last week we're doing on here, and then we'll have half-term week, where you will then be able to sign up for a class if you like. The details will come up shortly, but obviously with all of this, they should be more than prepared. But if you want that final push where we go through another set of questions, you're welcome to sign up for the masterclass. Good luck with all your revision. Make sure you ask any questions, and I look forward to hearing from you soon.